say that thing. There we go. All right. So when I'm looking at 14, 15, and 16, looking at those ones pretty quickly, if we're finding a formula of t based on r composed with p, we need to get that rule that's going to nest p inside of r. Our p formula is just 1840t. I'm going to put that in place of our t in the r equation. So this just means instead of having 50 minus t over 100, we'll have 50 minus, and instead of t, I'm going to write everything in the p equation, everything in function p. 1840t goes in place. So I'm putting that in a separate color to kind of stress that idea. We have our p function nested in place of the variable in the r. And so we have something like this. We could leave it like that. Mathematicians start to get really picky about how they want things done. So we could just simplify this second fraction. That 50 is not being divided by anything, so I'm going to keep that 50 just as it is. 1840 divided by 100 gives us 18.4 t. So it's just a slightly nicer way to write that. I know if I gave that to my Algebra 2 kids, they'd be a little less scared of it. Yeah. On this excellent question, the second t on the outside that we have here, we don't need to do anything with that because all this is saying is we're going to still have a function. It just happens to be a composite function in terms of t. So every time that you've seen like f of x, we have a function using x as the variable. That's all that this is saying here, that we're going to have a function that uses t as the variable. So we don't have to multiply it again. That's a really great question. This is just still reinforcing the idea that we need to do the composite function first. That's why it's in parentheses. And it's going to be in terms of t. And we have a function that is in terms of t, so that looks pretty good. So then comes the hardest part, the idea of interpreting what the heck these numbers mean. Because if you're sitting here, you're probably pretty good at the numbers game, but maybe not so great at the interpretation game. What does it mean to actually have an altitude in meters of a small plane, t minutes into a time to cruising altitude, and then we have another thing that tells us the temperature and altitude when it's t meters from the ground temperature, and it's like, whoa, what just happened? So what we're essentially seeing is that t is going to definitely be, we have a time value going on here. T meters, t minutes. So we have two things going on, t meters and t minutes. And what we have to think is which one is applying first. When we're applying r composed with p, t is going to be based on which we plug in first. Since we plug the t into the p function first, since that's the one that we're taking and picking up and nesting inside the other one, I'm going to use the t from the p function. Remember, we're picking up this whole function and nesting it inside. So it's going to tell me the number of minutes, something about this. So it should be number of minutes. And then I have to figure out, well, number of minutes of what? So P tells us the altitude in meters, T minutes into its climb to a cruising altitude. All right, well, there it is. T is our number of minutes into the climb. If we had put T into R first, if it was the other way around, if we had P composed with R of T, and we were plugging T into R if that one came first and then nested inside the others, I would use the T value for the R equation. And this is telling me T meters, so it's kind of interesting. That depending on which one goes first is the one that we're going to use. So in here, since we're plugging P into R, we're going to use the T value for the P function, helping us out right up there. Once we know that it's the minutes into the climb, it's like, okay, so what is this ultimate thing finally going to tell us? And since we take P and we plug it into the R equation, since we were taking this whole thing and plugging it into R, our result is going to be that R equation. Our result is telling us temperature at an altitude. So ultimately, since we took the entire P function, put it into R, and R is like the big, giant mama nesting doll that we're using, this is what the final output is. So there's our nesting doll idea for taking a smaller function and putting it inside a larger one. Whatever is the largest nesting doll that we're going to end up with, that's what the final function is helping us measure. So what we're seeing is that it's going to be temperature in degrees Celsius at an unknown altitude after however many T minutes into the climb. This is important stuff for pilots to know, because if you start going up too high, your plane doesn't work and function as well at colder temperatures. I took a couple years of aviation. I was going to get my pilot's license, and we had to calculate this kind of stuff. It was kind of cool to sit there and think about how the temperature gets colder and colder.